Okay, last unit, or last section for this unit is triangle similarity. Over the last week or so, we have been talking about similarity of any type of polygon. So parallelograms, just a basic quadrilateral. We've looked at triangles, right? Now there's an important question that I've asked you a million times. Let's see if we know the answer to it this time. What are two things you need to show to prove that two figures are similar? The angles need to be congruent and sides are proportional. So the angles need to be congruent and the sides need to be proportional. This is if we're showing any figure is similar. Okay, it's any figure. A parallelogram, a kite, a rhombus, a triangle, anything we choose, we need to show all angles are congruent and that the sides are proportional. When I'm talking about sides being proportional, what am I specifically referencing? What's the question again? When I'm saying I need to know if sides are proportional, what am I specifically looking for or referencing? A ratio, which leads to scale factor. So when we're talking about proportional sides, we're talking about scale factor. Okay, so that is for any figure. Now, I'm going to show you like a trick to help you with triangles. In IM1, you learned about congruent triangles, and you learned that there were 5 ways to prove triangles were congruent. Whether you remember that or not, I don't know, but you learned 5 ways to prove triangles are congruent. There are 3 ways to prove triangles are similar. So instead of showing all the angles are congruent and all the sides are proportional, we can use one of these 3 ways. Okay, 3 ways to prove triangles are similar. The first way is angle-angle. The second way is side, side, side. And the third way is side, angle, side. Okay, these are the only 3 ways to prove triangles are similar. Congruent triangles, there are 5 ways, and these 2 also are for congruency. That first one is not, but this shows that your triangles are similar. Now, just like before, the angles, if we're looking for an angle, it has to be congruent. If we're looking at side lengths, they have to be proportional. Okay, so that stays the same, except we only have to find this information. Okay, so angle, angle, side, 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 angle, side. Now, before we do a problem, we need to do a little bit of review. Who remembers information about parallel lines and transversals? What's that? Okay, so let's write it down. So we know what parallel lines are, right? 2 lines are parallel if they never intersect. So those lines are parallel. And then a transversal just cuts your parallel lines. Okay. Now there are different types of angles that are created by those parallel lines and transversals. I'm going to give you the first one, and then I think you'll be able to remember some of the other ones. So the first one is alternate interior angles. Do we remember that term? Yeah. Yeah? Now we have a couple, let's break down what alternate interior angles mean. So what does alternate mean? Opposite. So this alternate is going to be opposite sides of the transversal. What does interior mean? Inside the parallel lines. So opposite interior angles will be this angle here and this one here. They're on opposite sides of the transversal inside the parallel lines. Is there another pair of alternate interior angles?
Yeah.
I should probably do it like this. Those are also alternate interior angles. Okay, so that's how we can abbreviate that one. Does anyone remember another one? Alternate exterior angles. So we'll abbreviate it, whoops, like that. So alternate means opposite sides of the transversal. Exterior tells us it's on the outside of the parallel lines. So alternate exterior angle there with this one here. Opposite sides of the transversal outside the parallel lines. Are there any more sets of alternate exterior angles?
Yes.
These ones, right? Someone remember another one? Okay. Your teacher used consecutive interior? I use same side interior. Same thing. Consecutive's fine. Same side interior. They're on this, and I like same side interior because it tells you they're on the same side of the transversal inside the parallel lines. So for instance, here and there. Are there any more pairs? On the opposite side. I'm trying to use different like figures so you can see. There's two more that we're going to need to deal with. Corresponding angles. Nice. Okay, so corresponding is a tricky one. So same side of the transversal, I agree with that.
No, it's I know what it is. It's that X and the SSI.
So this X and which SSI? Yep. So corresponding and corresponding. So here's this one. It's on the same side of the transversal. It's also on the same side of the parallel line. So you'll notice they're both on the left of the transversal and they're both on top of their parallel line. How many more sets of corresponding angles do we have? Three more, right? So we have this one and this one. And then we have them match on the other side. So here and here. I know, there's a lot. If you know where one is, you know where the other are. So right now we have two of these, two of those, two of those, and four of those. Okay, I know that with all that it's confusing, but you need to know where at least one set is. There is one more super important one that we are going to use all the time. Okay, we should know what supplementary is. What does supplementary mean? They add up to 100 and 180, and they're going to be on the same line. So this line here, these two angles would be supplementary. Same thing in this direction. Okay, that's not the one I was thinking of, but also important to know. We already did alternate exterior.
I mean, same side.
We already did that. There is no same side exterior. I call them the kissing angles.
Oh, I know which ones. It's the ones that are like across from each other.
The vertical angles, nice. So vertical angles, and these are the ones we're probably going to use the most. Okay, vertical angles. Again, I call them kissing angles. I'm going to show you why. Because they literally face each other and like kiss. So these two angles here would be kissing angles. They're literally facing each other. These angles here would be kissing angles. How many more do I have? I have these here and these here. So this has a total of 4 for this picture, for the parallel lines and transversals. Okay, again, this is the one that we're probably going to use the most of, but you will see the other ones. So just be prepared for that. Huh? So for 3 lines, I know. Questions on that? I know that's all. That should all be review. Anyone not sure where we got some of those from? It's a lot of information, I know. Okay. So let's actually try some problems. So we are going to explain why the triangles are similar and write a similarity statement. Okay, so as you're drawing that, I'm going to just talk for a second. So instead of showing that all the angles are congruent and all the sides are proportional, we can use one of the 3 ways to show triangles are similar. So angle, angle, side, 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 angle, side. So as you're given a picture, you should look at the information you're given. Okay, are you given information about angles or are you given information about sides? Because you don't get to just make up numbers. So looking at this, are you given information about angles? I hear yes and no, and I'm going to come back to that question. Are you given information about sides? You know nothing about side lengths. You don't know what their distance is. Everyone agree with that? Which means we can't use side, 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 and we can't use side, angle, side, because we know nothing about the sides. Now, a lot of you said we don't know anything about the angles, but you do. What do these 2 lines or arrows represent? Parallel lines. So I have 2 parallel lines cut by a transversal. You think I gave you this information for nothing? Probably not, right? So I have 2 parallel lines cut by a transversal. So I'm going to extend out. Let's just pick one, and I'm going to extend out my parallel lines just so you can kind of see it, and pick a transversal, and let's see if we can figure out any of the angles. So kind of look at it as the 2 parallel lines cut by a transversal. Are there any angles there? So we know we're using angle, angle, right? I know I'm using angle, angle. Ignore that thing. Are there any angles that you think are going to be congruent based off this information up here? You have 2 parallel lines cut by a transversal. What 2 angles do you think are going to be congruent? The vertical angles. Absolutely. They face each other. I guarantee you're going to use vertical angles a lot. Didn't I say that was the one we were going to use the most? Okay, so vertical angles. Now here's the thing with writing about vertical angles. I can't just say angle Q is congruent to angle Q, because how many angle Qs do you technically see? 4. 1, 2, 3, 4. I need to know which ones you're talking about. So I'm going to say angle PQT. You should have learned in IM1 to name an angle using 3 letters. So PQT tells me it's this side. That's going to be congruent to angle RQS. RQS. And we know those are congruent because they're vertical angles. Any other angles congruent based off the information from above? It has to be inside the triangles. Thank you. Yeah. PQ what? Okay, PQS and PQR are here and here. They're not inside those two triangles. We can't use them. They have to be on the inside of those triangles. You cannot use PQS because that's this angle here. It's not in the triangle. We're trying to prove the triangles are congruent. Or similar, excuse me. PQR is a straight line. We're looking for angles.
TPQ is equal to RSQ.
TPQ. So angle P, because there's only one angle P, so I can just call it angle P, is going to be congruent to what angle? Why is it congruent to R? What type of angles are those? Alternate interior angles. They're on opposite sides of the transversal inside those parallel lines. Those two triangles are similar because we proved angle, angle. This is all you have to do here. So I like to write out what I'm proving, fill in the information, and then the last step is to write a similarity statement. So if I'm gonna call it angle triangle PQT, what would PQT be similar to?
RQS.
RQS. This is all of your work for that. That's it. But you have to be able to see it, okay? The hard part is just figuring out all the pieces. There's very little work involved. All right, let's try another one. This is going to take some practice. Do we see two triangles? Yeah? Okay. Now, what information are you given? You're given side lengths. Everyone see that? So what are our two options with side lengths? Side angle side or side side side. Now for side side side, I need to know all three sides. Do I know all three sides? No, I'm missing these bottoms, right? Which means I'm going to use side, angle, side. I just have to figure out where those angles are. But let's start with the sides, because that we know, right? So,
Will angle M and K be similar?
hold on, let's start with the sides. We're going to do one thing at a time. So let's start with this side. So what side? 2 would be similar to what? 6. The small to the whole triangle. Right? It's the small triangle to the whole triangle. So 2 over 6. What does that reduce to? 1 over 3. Which means when I fill in this side, I should also get a scale factor of 1 over 3. That one's going to be 3 over 9. 3 is the small. 9 is the whole. Does that reduce to 1/3?
Yes.
Okay, so we have our two sides. We need to find, yeah. Where'd I get the 9 from? The whole thing, 3 plus 6 gives me 9. That's why I say we want to compare the small triangle to the big triangle. Okay, so here's my small triangle, which is 3. The big triangle is this whole thing, which is 9. So I have my two sides. I need to figure out an angle. Do I know these two lines are parallel? No. So I can't use corresponding, alternate interior, alternate exterior. I can't really use anything from above. Is there an angle that both triangles have in common? Yes, Carlos, which angle?
JKL and JMA.
They have these two angles in common? They share those two angles?
Yes.
No. Which ones do they share? If I took that small triangle out of the big triangle, which angle is exactly the same?
J.
Angle J. Angle J is congruent to itself. Do you see that angle J is in the small triangle and angle J is in the big triangle?
Yes.
Anyone remember the property that says one angle can be congruent to itself from IM1? Starts with an R. No? How about the reflexive property? Does that sound familiar to you? No? Okay, well now you know. Reflexive property. So you need to look for angles that they possibly share. Now, if it showed that these two lines were parallel, then I could have used K and M because those would have been corresponding angles. But I don't know that those are parallel. It doesn't tell me that information. You can't just assume it. I want you to write a similarity statement. Since we know by side angle side that these two triangles are similar, write a similarity statement. Write a similarity statement. That's this. For these two triangles, though. Someone who hasn't helped me today, can you give me your similarity statement? Go ahead, Jacob.
MJN and KMJ.
MJN would be similar to K.
Wait, no.
So MJN would be similar to KJL. Good. If yours is different, that's okay. You just need to make sure they match up. The J's should be in the same location. Everything should match up.